Designers can achieve big reductions in the embodied carbon in buildings. Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer, is talking with in-house experts about how they're reducing the effect of buildings on climate change. Here's how Embodied Carbon is a production of Thornton Tomasetti.
Hi, and welcome to episode 7 of Here's How Embodied Carbon. This series explores how engineers and designers can reduce embodied carbon, or the emissions associated with building materials, and also minimize the negative impacts of buildings and other structures on climate change. I'm Amy Hattan, Corporate Responsibility Officer for Thornton Tomasetti, an international multidisciplinary engineering and consulting firm. We've been focused on embodied carbon for over a decade and are channeling all of our capabilities to tackle climate change. I'm talking with technical experts from across the company about the paths they are taking to achieve the greatest reductions in greenhouse gas emissions on their projects. Today, I'm talking with my colleague, Heather Walters, a vice president in our sustainability and resilience practice. Heather is an expert in sustainable design certification, and she also co-leads the education working group for our embodied carbon community of practice. Today, she'll be sharing lessons from a project where we did life cycle assessments, or LCAs, in 3 ways with very interesting results. Hi, Heather.
Hi, Amy.
I'm very interested to hear about this fascinating project that turned into an unexpected case study on how the results of popular LCA tools can differ.
Okay. To set the stage, this client had very aggressive sustainability goals, and embodied carbon was central to these from the beginning of the project.
All right. That explains the extra attention on conducting LCAs. Which study did you start with?
The first embodied carbon assessment that we did used Beacon, which is a Thornton Tomasetti plug-in tool that measures the embodied carbon of structural materials inside a Revit model. Beacon concentrates on the primary structural materials, concrete, metals, timber. The embodied carbon data in Beacon is for A1 through A3 life cycle stages. So those are for the upfront embodied carbon emissions only: raw material harvesting, transport, and manufacture. So this data doesn't include the operational or end life stages of a material. In Beacon, the global warming potential and embodied carbon values are set at industry averages, but the user can adjust those if there's a reason. So for this project, we did a Beacon study very early in design, measuring the embodied carbon of the structure for A1 through A3 emissions. And then we compared it to a real building that had just been completed by the same client in the same region and a similar lab use, which made it a really great baseline.
Yeah, that sounds like a great baseline.
Exactly. And when we compared the embodied carbon of this building to our project, it showed a 27% reduction in global warming potential in the structural system. That reduction was the result of structural design optimizations, as well as concrete mixes with really high cement replacements.
27%, that's good. So did you stop there and celebrate your winnings?
Not yet. Later in the design, we did a second run using Click LCA. This online tool we use for LEED because it meets the requirements of the LCA credit, and it has a robust database and is flexible. Click also covers the additional life cycle stages of materials. And for LEED, we have to assess enclosure as well as structure. So at the design development and again at construction document phases, we use Click to do another round of LCAs.
Okay, and how did those turn out?
Well, it was different, still correct, but tools measure different things. And since the Click tool measures additional life cycles, we have to set a calculation period, which we use 60 years. And this calculation also included the building envelope, whereas our initial Beacon study focused only on structure. The second assessment showed a 17% reduction in global warming potential compared to a LEED baseline, which is a similar building using industry average materials. We often look at cement replacement, which, for example, has a regional average of around 20%, whereas for projects like this with more ambitious sustainability goals, we'll use upwards of 40% for a replacement.
I get it. You started with Beacon in early design, and then you moved on to One-Click to meet the LEED credit and to include additional building elements. But because the third time is the charm, you decided to do one more assessment, right?
Of course. But we were hoping to get more than good luck from this third and final embodied carbon assessment. We did this one at the end of construction and used the EC3 tool, or the Embodied Carbon in Construction Calculator. It's an online tool that's often used during the procurement phase. EC3 is specifically for determining the upfront A1 through A3 emissions, similar to Beacon. It's a database that has structural, envelope, and interior materials, and it's always expanding. But our EC3 assessment only included the structure and enclosure because the project was core and shell only.
Aha! You did this at the end of construction. It sounds like a test of your early design goals and is a good comparison with the early Beacon study. But maybe EC3 isn't an exact comparison for Beacon.
No, it's not. In EC3, the baseline doesn't account for any design optimizations. You take the materials you've used and enter the quantities of each. You match each product to a specific EPD, which tells us the embodied carbon of that product. And then the tool compares that with an industry average. So we did this for a variety of structural and envelope materials for the project. And our results were fantastic. We came out with a 36% global warming potential reduction, which we were very pleased with. And then we sent our report over to the client, and they came back and they said that reduction was much greater than what they had anticipated.
Wait, what?
Yeah, I know. We talked with them and we learned that they didn't want us to include any reductions for materials unless we had a type 3 product-specific EPD. This was their corporate policy.
Bummer. A 36% reduction would be something to celebrate. So what's the deal with this type 3?
Well, EPDs are environmental product declaration, and type 3 EPDs are the gold standard because they're third-party verified. This was an issue for us because none of the concrete suppliers in the city this project was in had type 3 EPDs. Our concrete specifications had included embodied carbon requirements, so we've been collecting global warming potential numbers from concrete suppliers throughout the project, but we didn't actually have product-specific EPDs for the mixes. So according to the client's policy, we couldn't count the savings. So we went back, redid the EC3 study, claiming savings only for products that had type 3 EPDs, and now we only were demonstrating a 4% global warming potential. That's not what we were hoping to see. But since we couldn't take credit for using concrete mixes with high cement replacement, it made sense to us. And the client felt this number made sense too. Although now, a couple years later, type 3 EPDs are becoming available in this market, partially because of projects like this that we're asking for it. So next time we do this exercise, we'll be able to show a much higher savings.
In the 3 embodied carbon assessments that you did, there was a surprisingly wide range of results for embodied carbon reduction, from around 30% to just 4%. Why the difference?
Well, we did the 3 assessments using 3 different tools, included different parts of the building, and used different baselines. Our main takeaway from all of these exercises is that it's very important to really understand the purpose of a particular embodied carbon assessment. We need to make sure the study is answering the right question, and that question might be different at every phase of a project.
Okay, so what are the right questions?
What other building elements should be included? Can we take credit for material reductions and optimizations? What's your baseline? And most importantly, what's your goal? Knowing this early on in a project is really critical so we can select the right strategies to yield the right results to meet our clients' goals.
So embodied carbon reduction starts by asking questions. I think that's a key lesson because architecture and engineering professionals looking for embodied carbon reductions often start with a tool. But the tool isn't all that useful unless it's answering the right questions.
Yes, Amy, that's absolutely true. And I think this case study really demonstrates that.
Thanks a lot, Heather. Folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.